What problem does the proposed method DITTO aim to solve in the context of aligning large language models, LLMs, to specific settings?
The proposed method DITTO aims to solve the problem of aligning large language models, LLMs, to specific settings by efficiently communicating preferences and aligning the language model to new individuals or tasks using a small number of user-provided examples of desired behavior. DITTO addresses the challenge of mismatch between the universal style trained into an LLM and the specific style needed for applications by leveraging user-provided demonstrations to scaffold a dataset of preference comparisons. This method allows for fast adaptation in data-limited settings and outperforms existing approaches like supervised fine-tuning, SFT, self-play methods like spin, and few-shot prompting by providing a more sample-efficient way to align LLMs to individual preferences. DITTO generates comparison datasets for alignment by using expert demonstrations and model outputs, eliminating the need for collecting a large number of pairwise preferences. The method also incorporates online imitation learning, allowing the model to extrapolate beyond the performance of the expert, thus achieving strong alignment with individuals.
How does the proposed method DITTO work? Provide a detailed step-by-step illustration of its methodology.
DITTO works by leveraging a small number of user-provided examples of desired behavior, typically around 5 demonstrations. These examples are either drawn from a user's existing interaction logs or from direct edits made to LLM outputs. The approach scaffolds these demonstrations into a dataset of preference comparisons by treating the user's demonstrations as preferred over model outputs from both the original LLM and earlier training iterations. This augmented dataset is then used to update the language model using an alignment algorithm like DITTO. DITTO can be interpreted as an online imitation learning algorithm, where data sampled from the LLM is used to distinguish expert behavior. The key insight of DITTO is that the LM itself, along with the expert demonstrations, can generate comparison datasets for alignment, eliminating the need to collect a large number of pairwise preferences. By generating comparisons between expert demonstrations and model outputs, DITTO constructs an unbounded preference dataset given only a few demonstrations. Additionally, DITTO considers the temporal aspect of the learning process by generating comparisons using all policies learned over time during RLHF, leading to a progressively more diverse comparison dataset using all prior policies. This methodology allows for the alignment of LLMs to specific settings by providing a small number of demonstrations, making the process more efficient and effective compared to traditional methods that rely on large amounts of paired comparisons.
What are the theoretical or practical benefits of using DITTO compared to existing methods like supervised fine-tuning, SFT, self-play methods like spin, and few-shot prompting?
The theoretical and practical benefits of using DITTO compared to existing methods like supervised fine-tuning, SFT, self-play methods like spin, and few-shot prompting are significant. The paper demonstrates that DITTO outperforms SFT, spin, and few-shot prompting in aligning large language models, LLMs, to specific settings by leveraging a small number of user-provided examples of desired behavior. DITTO achieves strong alignment with individuals by scaffolding user demonstrations into a dataset of preference comparisons, updating the language model using an alignment algorithm like DITTO. DITTO can be interpreted as an online imitation learning algorithm, where data sampled from the LLM is used to distinguish expert behavior, allowing it to extrapolate beyond the performance of the expert. The key insight of DITTO is that it generates comparison datasets for alignment, removing the need to collect a large number of pairwise preferences, making it more sample efficient. Additionally, DITTO does not require external signals besides demonstrations, unlike other methods that may rely on additional signals or large datasets for effective alignment. Overall, DITTO's ability to efficiently align LLMs to specific settings using a small number of demonstrations sets it apart from traditional methods, making it a more practical and effective approach for personalized alignment tasks.
How is the method DITTO validated or tested in the paper?
DITTO is validated and tested in the paper through a series of experiments and a user study. The experiments focus on tasks with subjective preferences, such as email writing, essays, and articles. The paper compares DITTO against several baselines, including continued supervised fine-tuning, SFT, self-play methods like spin, and zero-shot and few-shot prompting methods. The evaluation is conducted using GPT-4 to compare the outputs of models across various conditions. The results show that DITTO outperforms all baselines, with an average win rate of 77.09% across different datasets. Additionally, a user study is conducted where participants provide demonstrations for email writing tasks, and their preferences are collected through pairwise comparisons. The results of the user study also demonstrate that DITTO outperforms baseline methods in aligning to demonstrated preferences, with a win rate of 72.1%. The study further reveals that users struggle with verbalizing preferences into prompts, highlighting the effectiveness of demonstrated feedback in the interaction.
What results were achieved with the DITTO method in the experiments, particularly in the user study and automatic evaluation?
In the experiments, particularly in the user study and automatic evaluation, the DITTO method achieved significant success. In the automatic evaluation, DITTO outperformed all baselines, with an average win rate of 77.09% across both CMCC and CCAT 50 datasets. DITTO consistently outperformed SFT, spin, zero-shot, and few-shot prompting methods, showcasing an average improvement of 11.7% over SFT alone. In the user study, DITTO also excelled, with a win rate of 72.1%, surpassing SFT few-shot prompting, self-prompting, and zero-shot prompting. Users struggled to verbalize preferences into prompts, highlighting the effectiveness of demonstrated feedback with DITTO. Overall, DITTO demonstrated superior performance in aligning LLMs to user preferences compared to other methods, showcasing its effectiveness in both automatic evaluation and user studies.
What are the limitations or drawbacks of the DITTO method presented in the paper?
The limitations or drawbacks of the DITTO method presented in the paper include the need for careful selection of demonstrations, as the quality of provided demonstrations can affect DITTO performance. Additionally, there is a trade-off associated with increasing the number of negative samples in DITTO, as more negatives improve performance but also increase runtime. The performance of DITTO can vary from user to user, indicating potential challenges in generalizing its effectiveness across different individuals. Furthermore, there is a risk of potential overfitting if the reference model is continuously updated during the online training process. Another limitation is that early iterations of DITTO may yield noisier samples, potentially reducing performance temporarily. Lastly, while DITTO is sample efficient, there may be diminishing returns in performance as more demonstrations are provided, suggesting a saturation point in its effectiveness.